Hello and welcome to the Scientific Process video 2. At this point, you should have completed your concept map. If you haven't done that yet, go ahead and pause the video and go complete filling that out now. Here is mine, okay? It looks a little busy, that's fine, and it probably looks different than yours, and that's fine too. Like I said before, there's no one right way to do this. I will say though, something's wrong with mine. Go ahead and pause the video and see if you can figure out what I did wrong. Did you find it? I have data in here twice. When concept mapping, we don't want to include concepts in multiple places. We want to keep it just in one place and draw connection lines between that concept and all of the other concepts. So to fix this, I'm going to need to remove one of these two instances of the concept data. Now, because I've already included a lot of lines to the data box up on the left, I'm going to delete the other one. And this is what that looks like. If you need to copy this into your notes, go ahead and pause the video now. Another thing that I want you to recognize about the scientific process is that it really has no clearly defined beginning and end. Sometimes it's easy to consider it a linear process. You make an observation, generate a hypothesis, collect some more data, analyze, interpret, and come up with conclusions that you then share with others. However, in reality, the process is much more iterative than that, right? So maybe you make an observation, you come up with a hypothesis, you go to the lab to test it, you end up having to tweak that hypothesis, you go back to the lab, you tweak it again, you'll get some data, you analyze it, you come up with conclusions, you share it with other scientists, they encourage you to go back and have another think on it, maybe do some more experiments, update that hypothesis, do some analysis, share your results. So really, these different processes can happen multiple times as we go about attempting to learn about the world around us. Remember, the ultimate goal of the scientific process is to give us a structure with which we can attempt to determine how the natural world works. Of course, not all science is good science. This can be of particular concern when reading about science reported in the popular media, and it's something you should watch out for. Common pitfalls include attacking scientists rather than science. Okay, a lot of times if things are politicized, for example, or if people perceive there to be a disconnect with religion, then people will attack the scientist who's doing the work rather than the actual work itself. And that's not a valid argument, okay? Science, the scientific process enables data to sort of stand on its own, and attacking someone's character or belief system can't validate or invalidate the science that they have done. Another common pitfall is the misuse of authority. This can happen when politics, again, conflict with science. If something is not politically tenable, then oftentimes people in authority might say things for or against it that aren't necessarily based on the scientific process. This is something we should definitely be looking out for when we watch the news, for example, or when we hear about our officials making any sort of statement about science, either positively or negatively. Another example would be confusing cause and effect. So an effect might be my book falls on the floor, and the cause might be I accidentally knock into the book, which was sitting on a table. Now, on the other hand, if I walk up and I see that my book's on the floor and I assume that it fell off the table, so if I say, if the book fell, it must have been because I knocked it, That's not necessarily true. There are lots of reasons that a book could fall on the floor, and me being clumsy and knocking that off is only one of them. So it's really important to keep cause and effect in mind, right? So things can cause other things to happen, but if you see that something happened, it doesn't necessarily tell you what the cause was. Another example that can lead to bad science is poor statistics. So if you collect this data set but you analyze it improperly, then that can lead to interpretations that are just incorrect. Okay, so you have to be really careful with any sort of data manipulation, that you know what you're doing, are following established procedures to come up with results that are statistically relevant and valid. Okay, that concludes this video lecture on the scientific process. Hopefully at this point you can define all of the terms that you see here, and you can also relate them to one another in ways that make sense so that you can talk about the scientific process, explain what it's used for, how it's used, what the different steps are, and why all of this is important.